Alrighty, this is the long-awaited demo of QuintupleO. For anyone who's not already familiar with that, hopefully I've included a link to my blog post that talks a little bit more about it, along with wherever you found this video, but I'll try to cover the 30-second introduction here. And basically, that would be QuintupleO is a method for using OpenStack instances to simulate real bare metal hardware. And the main focus behind this work has been allowing QuintupleO to deploy to OpenStack instances instead of bare libvirt instances that we have to manage ourselves and deal with the networking and all of that stuff. So that's the really quick introduction. There should be more information out there if you're curious about the details. So we'll go ahead and get started here. What we're looking at right here in this top window is an SSH session to a DevStack installation with a few modifications that, again, I talk about in my blog post. And this is the thing that's going to contain the instances that we deploy to with QuintupleO. So the first step of that process is going to be deploying a heat stack that takes care of deploying and setting up the bare metal and BMC instances. And the reason we need two types of instances is that just like in a real bare metal environment, you're going to have the actual bare metal machine, in this case a virtual machine, that gets deployed to, but there's also going to be a separate little instance running there that is running an IPMI listener that knows how to talk to OpenStack and is able to start, stop, and do all the IPMI things with the bare metal instance. So this heat template that I'm showing here, or not showing, you can see the files at least, is going to take care of all of that setup. And this is actually available in my GitHub repo, which hopefully I've also linked somewhere related to this video. So we'll go ahead and deploy that. You can see what command we're going to use. And we just need two nodes. The overcloud we're going to deploy here is just an overcloud control and compute instance. And so the heat stack is creating. And we can see the instances coming up here. While they're building, I can go ahead and talk real quickly about the networking. I've tried to simulate a real bare metal setup with the networking as well. So what we have is just a private network that's what you would find in most OpenStack installations. That would be essentially the site-wide or public network of a real bare metal environment. That's what you would use to talk to these systems once they're deployed. The other network is the undercloud network, and that's actually the provisioning network that we'll be using to do the Pixie boots and TFTP and all of that good stuff for the ironic deployments. And you can see the BMCs are not on the provisioning network because they don't need to be. They just need to be able to talk to the DevStack, OpenStack that we're dealing with here. Okay, so looks like our heat stack has completed. There we go. So the next step is to go out and take a look at those four instances we just deployed and collect their details so that we can stick that into a JSON file that QuintupleO will understand and can use to register the nodes with Ironic. And you can also see, I should have mentioned, I do have an undercloud node already booted and ready to go. That's not really the interesting part of this process, so I just did it ahead of time. So as far as collecting the details of the new VMs, I have a script for that as well, and it's just called that. Again, available in my Git repo, so if you want to use it, you can find it. And you can see that's output some JSON. It also stuck it into a nodes.json file. So we'll go ahead and copy that nodes.json file to the undercloud node. And then we'll go ahead and go down here to the undercloud node and put that in the place that the deployment script's expected to be. This is an undercloud deployed with instack, actually instack undercloud. So that's why I'm renaming the file, because that's what instack expects it to be. So then we'll go ahead and make sure we are sourced into the stack RC and go ahead and register the nodes. And there you can see we have 2 new ironic nodes, and those should correspond to our 2 bare metal machines. And as you'll see, if we go back over to the dev stack window, those 2 bare metal machines are now powering off due to the ironic state assertion that expects newly registered nodes to be off. So that will take just a minute to complete. Those bare metal machines are set up to PXE boot by default, so they'll be hung looking for deployment files that they don't have yet. So it takes them a second to actually shut off, but it will happen. Okay, and you can see both of the bare metal nodes are now off. So we can go back over to our undercloud and go ahead and run discovery on those nodes. And this process does take a while, so chances are good that I will cut out part of this recording. But we can come over here to the DevStack Horizon instance, and you can see we have our 4 VMs that we created earlier. And any time now, the discovery code should be starting those up. And there you go, we can see they've gone to active now. And then just real quickly, I will pull up the console for these instances, or at least one of them, and show the discovery RAM disk at work, just so you can see that it is doing what you would expect a bare metal deployment to do. Just waiting a minute here because there's a lot of text output from the discovery RAM disk early on, and it tends to make the VNC console hang. And here you can see in the VNC console for the bare metal instances that it is indeed running the discovery RAM disk and finding out everything that it can about the environment that it's running in. And that'll probably about do it for this step, so expect a cut right about here. And we're back. So you can see both of the nodes have now been discovered, and we can go ahead and take a look at what profiles they were assigned. So you can see one compute, one control. That's exactly what we want. So we will set up some bare metal flavors for doing the actual deployment to those profiles. And as you can see, I had already created them on this undercloud, so there wasn't anything to do for that, but that's how you would do it. And then we should be all set up to go ahead and deploy ourselves in overcloud. And here again, this will be a fairly long process, so expect the cut to be coming shortly. We can go out here and take a real quick look at what the deploy RAM disk is doing. Again, I'm going to wait just a bit to give it time to get past the wall of text part of the process. And also to actually get started on the deployment process. There is some delay here as we wait for images to get moved around and converted and all of that stuff. Alright, and you can see this is the kind of end result of the deploy RAM disk. What it's doing right here is just waiting for Ironic to notify it that the deployment is complete and it can go ahead and reboot into its shiny new overcloud image. So that'll do it for this section, and we'll be right back with hopefully a functional overcloud. And we're back again. You may notice that there are a few things that look a little bit different this time. I went ahead and re-recorded the end of this video just because the original recording had some not quite fully functional overcloud images. But the ones that I'm using today should work for everything that we're going to test anyway, so we'll go ahead and kick that off. And all the script is going to do is exercise a few of the OpenStack services on the overcloud and just verify that everything is working in a reasonably sane fashion. And I'll probably go ahead and speed up part of this section just so we don't have to sit here and wait for the entire process. It does take a while for the nested instance to boot and do all of its work. And as you can see, our sanity test has completed. We verified that Nova and Neutron and Cinder and Glance and Swift are all working, and looks like we're good to go. So that's my demonstration of deploying a cloud in a cloud using a third cloud, and I hope you enjoyed it. Thanks for watching.